Welcome back to Spring into Math 7. I'm Mrs. Campbell, and today we're going to be talking about equations with variables on both sides. Let's jump in. So when the variable appears on both sides of an equation, we need to manipulate our equation such that all the variables appear on one side and only constants remain on the other. So that's basically the gist of solving equations with variables on both sides. Let's jump right into an example. Dwayne was told by his chemistry teacher to measure the weight of an empty beaker using a balance. Dwayne found only 1 pound weights. And so he devised the following way of balancing the scales. And you can see there the weights and the beakers. So knowing that each weight is 1 pound, calculate the weight of one beaker. Here's our solution. We know that the system balances. So the weights on each side must be equal. We can write an algebraic expression based on this fact. The unknown quantity, the weight of the beaker, that's going to be our x. We can see that on the left-hand scale, we have 1 beaker and 4 weights. On the right scale, we have 4 beakers and 3 weights. The balancing of the scales is analogous to the balancing of the following equation. X plus 4 equals 4x plus 3, or 1 beaker plus 4 pounds equals 4 beakers plus 3 pounds. So to solve for the weight of the beaker, we want all the constants, or the numbers, on one side and all of the variables, or the terms with x, on the other side. Now, there are more beakers on the right and more weights on the left. So we'll aim to end up with only x terms, or beakers, on the right, and only constants, weights, on the left, which gives us, here's our equation, x plus 4 equals 4x plus 3. We're going to subtract 3 from both sides. We get x plus 1 equals 4x. Now we'll subtract x from both sides. We get 1 equals 3x. Next, we will divide both sides by 3, and we get x equals 1/3. So the weight of the beaker is 1/3 of a pound. Now, we can do the same with the real objects as we've done with the equation. Our first action was to subtract 3 from both sides of the equal sign. On the balance, we could remove a certain number of weights, or beakers, from each scale. Because we remove the same number of weights from each side, we know that the scales will still balance. On the balance, we could remove 3 weights from each scale, and this would leave 1 beaker and 1 weight on the left and 4 beakers on the right. So in other words, x plus 1 equals 4x. The next step we could do is remove 1 beaker from each scale, leaving only 1 weight on the left and 3 beakers on the right. And you'll see our final equation, 1 equals 3x. Looking at the balance, it's clear that the weight of the beaker is 1/3 of a pound. Pretty simple. Let's talk a little bit about solving equations with grouping symbols. So when we have a number of like terms on one side of the equal sign, we collect like terms and then add them in order to solve for our variable. When we move variables from one side of the equation to the other, we sometimes call it grouping symbols. Essentially, we're doing exactly what we would do with the constants. We can add and subtract variable terms just as we would with numbers. In fractions, occasionally, we will have to multiply and divide by variables in order to get them all on the numerator. So, example here is, solve 3x plus 4 equals 5x. So this equation has x on both sides. However, there's only a number term on the left. So therefore, what we're going to do is move all the x terms to the right of the equal sign, leaving the constant on the left. So we have 3x plus 4 equals 5x. All we have to do, same thing, inverse operation, is subtract 3x from both sides, which gives us 4 equals 2x. We divide by 2, and we get the solution, x equals 2. Here's another example. Solve 3x plus 2 equals 5x over 3. Again, this equation has x on both sides, and it also has a fraction. So it's always easier to deal with equations that don't have fractions. So the first thing we want to do is get rid of that fraction. Here's our equation. So the first thing we do is we multiply both sides by 3, distribute the 3. We get 9x plus 6 equals 5x. We're going to subtract 9x from both sides. We get 6 equals negative 4x. We're going to divide both sides by negative 4. and we have 6 over negative 4 equals x, or negative 3 over 2 equals x. So the solution is actually going to be negative x equals negative 1.5. Another example, solve the following equation for x. 14x over x plus 3 equals 7. So the form of the left-hand side of this equation is known as a rational function because it is the ratio of two other functions, 14x and x plus 3. However, we want to solve for x, so we start by eliminating the fraction. We do this, as we always do, by multiplying by the denominator. So we have 14x over x plus 3 equals 7 times x plus 3. So once we multiply by the x plus 3, then we get 14x equals 7 times x plus 3. We'll distribute that 7. We get 14x equals 7x plus 21. Then we're going to subtract 7x from both sides. We get 7x equals 21. And dividing both sides by 7, we see that x equals 3. Let's talk about solving real-world problems using equations with variables on both sides. So it's really important to build on your skills translating problems from words into equations. Ask yourself, what's the unknown variable? What quantity will we use for our variable? So the text explains what's happening, and what you want to do is break it down into small, manageable chunks, and then follow what's going on with your variable all the way through the problem. Here's a little bit more on Ohm's law. The electrical current I, amps, when passing through an electronic component, varies directly with the applied voltage, or V, volts, according to their relationship. So V equals I times R, where R is the resistance measured in ohms. So the resistance R of a number of components wired in a series, one after the other, is given by R equals R1 plus R2 plus R3 plus R4, and so on and so forth. Here's our example. In an attempt to find the resistance of a new component, a scientist tested in a series with standard resistors. A fixed voltage causes a 4.8 amp current in a circuit made up from the new component plus a 15 ohm resistor in a series. When the component is placed in a series circuit with a 50 ohm resistor, the same voltage causes a 2.0 amp current to flow. Calculate the resistance of the new component. So again, this is kind of a complex problem to translate, but once you convert the information into equations, it's relatively straightforward. First, you're trying to find the resistance of the new component in ohms. That's going to be your X. We do not know the voltage that's being used, but we can leave that as simple V. Our first situation has the unknown resistance plus 15 ohms. The current is 4.8 amps, so you substitute into the formula V equals I times R. V equals 4.8 times x plus 15. Our second situation has the unknown resistance plus 50 ohms. The current is 2.0 amps, so that gives us V equals 2 times x plus 50. We know the voltage is fixed, so the V in the first equation must equal the V in the second. That means that 4.8 times x plus 15 equals 2x plus 50. We're going to distribute those constants. We get 4.88x plus 72 equals 2x plus 100. Subtract 2x from both sides. We get 2.8x plus 72 equals 100. Subtract 72 from both sides. We get 2.8x equals 28. Divide both sides by 2.8x, and you get x equals 10. So the resistance of the components is 10 ohms. So let's quickly summarize our lesson in this. If an unknown variable appears on both sides of the equation, distribute as necessary, then subtract or add one term to both sides to simplify the equation to have the unknown on only one side. Thanks so much for joining us. That does it for this lesson, and we'll see you next time. Bye-bye.